in today's video, got this question for 6 marks. The question is, we've got first part and second part. First part 3 marks, and second part we got 3 marks here as well. It's that easy to go for. We're gonna go through step by step and see how we can solve it. All right, for the first question says, we've got here first, we've got S and T. They are complex numbers. S and T, we've got the definition of S, we've got definition of T. First question will be asked, just make separation. For the first question, we've been asked to find the modulus, which, as we said, is the length. In the previous video, we explained what modulus means, and modulus of ST. This rating means ST is basically is the same as S times T, as simple as this. We've got S, we've got T. Before we basically calculate the modulus, we have to find what is S times T. Then, as simple as this, what we can do, we can now calculate S times T first, and then we can move on. S times T equals 2 minus 5i times 5 minus 4i. Equals here, just to simplify it, distribution 2 times 5 is 10, 2 times minus 4a is minus 8a, minus 5 times 5 is minus 25i, and then 5 times 4 minus 5 times minus 4 is plus 20, plus 20 times I square, which is minus 1, which is going to be minus 20 here, and then simplify again. It's gonna be, or we can go this way here. We're gonna have, let's get rid of this equals here, 10 minus 20 is gonna be minus 10, and then we've got here minus 8 minus, because this is real, we got real number, imaginary, got imaginary number, minus 8 minus 25 is gonna be minus 33i, and this is S times T. Now from here, we can calculate the modulus of S times T. It's basically this one in here, which we said, first thing we knew about the modulus, it has to be positive. As we said, it's the length, basically. To keep it simple, it has to be positive. Then what we've got for the length here, what we said, for the, if we want to calculate the modulus of any complex number, is going to be x squared plus y squared all square root. It's basically this way here, x squared plus y square all square roots. In here, our x is 10 square is 100, and we've got 33 square as well, all square roots, which is, if you just replace here these numbers, the end result is going to be 1189 square roots. That's all, as simple as this. All the simple answer for 3 marks. That easy, 3 marks. You see, it's kind of piece of cake to get you to get your 3 marks, as simple as this. For the second part in here, we're still using the same S complex number, the same second complex number, S and T. As I said in the past, S and T are just names. You can name it S, T, Z, or whatever. Now what we said, from the modulus, we're going to go to the arguments. We've spoken about the argument. We said show the argument of S plus argument of T equals argument of S times T. S and T are complex numbers. First thing here, what we have to do first is just we keep it simple here. We're gonna have your graph, and then you have to draw, you have to put your S and then T, just to make things clear, because here we're gonna calculate basically the argument is the angle from the real number here, axis of real number goes to here we got imaginary number. It has to be anti-clockwise, and then it has to be positive 2. It's basically, we said it's gonna be this way in here. It's not all the way around. Anti-clockwise, basically all the way around. Then we've got in here, if we just make it simple, 1 2 3 4 5, and then here 1 minus 1 minus 2 minus 3 minus 4 minus 5. We got here imaginary 1 2 3 4 5 minus 1 minus 2 minus 3 minus 4, and then here minus 5. Cool. Okay, now we're gonna go to, it's that simple. You can do it properly in your basically for your answer, but it's simple, piece of cake as well. For the real number for S is 2 basically here, and then for the imaginary number is minus 5. 1 2 3 4 5 with 2. We're gonna go this way here and there. This is our S here, all the way down here. This is S, and then we've got our what we call the our argument or our angle here is going to be this way here, which is, we call it omega 1 or beta 1, or any name you would like to name it. For now, we're going to go to the second complex number, which is t. We've got 5 minus 4. 5 for real number 1, for a real number, yeah, 1, 1, 2, 3, 4, 5. And then for the imaginary number, in minus 4, we've got 1, minus 1, minus 2, 1, 3, minus 4. And then we go this way here and that way here. And here is our t. It's basically S and T, just here to keep it simple for you. And then this is T. And then our second argument or second angle, it's gonna be omega 2. Basically, this is 1 and this is 2. We got in here, it's like basically a couple of, we can see few things. We can notice here. The first one, it's negative. Both of them are negative, and both of them is like it goes in a negative way for the imaginary number. For the real number is positive. Then what, or we have to put them, we have to put them here on the top, because we said it has to be positive and starting from here and moving forward, not from here. It's basically, you have to put them all the way up here. It's similar, or basically all the way around here. And then we have to change basically our symbol from minus from plus to minus, because you have to start from here, which is we're going to demonstrate in with a couple of numbers in here. Argument S, we're going to start here by calculating argument of S. Argument of S equals omega 1, and then equals in here. We have to calculate first omega 1, which is this one in here. We said is tan power minus 1 argument here modulus y divided by x. This will have to calculate this first. This is what we knew about it. And then from here, what we're going to have tan. We can find it is that simple. Don't complicate things in here. Just go to the calculator, scientific mode, and then we're gonna find it there. Tan minus 1 y. We got y, which is 5 divided by 2. Why did I say 5, not minus 5? Because we got modulus, it has to be positive. And then in here, if you go to your calculator and do it, you're gonna find it in here. It's gonna be 1.19. But and here from 1.19 with your calculator, we've got it this way here. It's 1.19, but we have to put it up here. S has to go up all the way up here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Basically have to go. Our S, it has to go in here. In here, basically, we have to make it from here till here. What we're gonna do then is gonna be minus, because this is negative. We'll have to make it positive. To make it from negative to positive, you had to times it by minus 1. This is our number times minus 1 is gonna be minus in here, radius or whatever you want to calculate it with. Then we've got argument of S equals minus 1.19. This is the first one. This is what the graph is really important. If you want to calculate the argument, you need your graph. You can't just use your brain and moving straight forward. With numbers, you're going to confuse yourself. Use the graph. This is for S. We go now to T. As simple as this. Argument, of T. T is the second complex number. It's the same rules. We've got tan minus 1 of the modulus y divided by x equals tan minus 1, just to keep it simple for you to use it in your calculator. Y times y divided by x equals 4 divided by 5. Here it's not in here, in our exercise it was minus 4, but in here I said 4 because modulus have to be positive. Use your calculator. It's gonna be O plus O times 67. Again, it's the same case, same situation. We have to make it here. It has to go up here. It's basically, we said 5, 1, 2, 3, 4, 5, but it has to be 4 instead of minus 4. We're gonna 1, 2, 3, 4, and then this way here, and all the way up. To go up here now, we have to get it there. Here we start from real number axis in here and we go anti-clockwise, it has to be positive. Then this way in here we've got our omega 2, which is negative. We have to make it positive, times it -1, and it's gonna be here minus 0.67. This is the argument of t. We found arguments of 1 and we found arguments of t. All we've got to do now, we have to find arguments of s times t, and then we've proven that we have to get the same results. Then we prove this equation is correct. This is what we have to prove. Now, argument of s times t. First, do we have s times t? Yes, here's s times t. This is not a complex number. Basically, it's kind of ask you to calculate the arguments of different complex number. But in here, we've got -10, basically -1, 2, 3, 4, 5, 6, 7, 8 till -10, and then just want to see what side the argument of this complex number is going to be. Is it this side, this side, this side, or this side? Because this is the key. This is really important. We've got -10 and we've got -33. Basically, the argument is going to be this side in here. We said we can't, basically it has to be, let's say, this way here. We can't just calculate it this way. It has to be this way up here, because we have to start from here and move on. Yeah, then what we have to do, we have to calculate it this way and then times it by -1, because we said it has to go on the top. We can't calculate the argument if it's on the bottom, and here we have to make it go on the top. How to do that? As simple as this, times it by -1. If it's this side of this side, times -1 and then bring it up here, as simple as this. Then if it's this side, all we have to do, times it by -1. If it's this side, to calculate it, what we have to do, we have to calculate basically to make it up here. What we have to do, we have to calculate this from here till here and then make it up here. Basically, it's going to be this side, just like this. To calculate this, because this the argument in here is going to be this side in here, basically from here, then we're going to have p minus p. It's from here till here, it's 180 degrees technically, from here till here, minus this side in here. But if it was here on the top, it's that easy. We do this way, which is p minus this, and then we're gonna have our arguments. But because it's in this way in here, we have to do the same calculation, the same way in here, and then times it by -1 to make it up here. As simple as this. P minus P, which is 180, all this angle in here, minus this tiny bit, and we're gonna find our arguments. But if it's here on the top, I'm just repeating here, we do this way. But if it's on the bottom in here, we do it this way, but times it by -1 to make it up here. Then here, what we have to do in here, we're gonna calculate it. It's gonna be -1, because it's here on the top, on the bottom. To make it on the top, we have to times it by -1, which is minus, open brackets, we said p, which is p, all of this in here, minus this angle in here, which is it's in here, tan. How do I know this? Because you've got real number negative and imaginary number negative. It's in this side in here, tan 1 of what? Of 33 divided by 10. This is what I have to calculate now. Y 33 divided by 10. This is our y. This is my y. Same rules. Y divided by x, but this is negative and negative in our calculation with numbers, but with modulus it has to be positive. 33 times 10. You use the calculator to calculate this instead of putting here, because in here is going to be number. We can't just do an angle take away number. Here we can't just say 180. Don't do that, 180 degrees, because we are not doing this. 180 degrees are just explained in a graph. You use degrees when you draw something, but with the numbers in here, it's 3.14. Remember this, is 3.14, is not 180. As simple as this, you do 3.14, take away this in here, and then we're gonna find that minus 1.86. As simple as this. And then what we have to do, we have to set, just get your calculator again, add this number to this number, which is minus 1.19, plus minus this way here, minus 1.19, minus, which is plus, minus because this is negative as well, 0.67. If you add them two numbers together, it's going to be minus 1 plus 8, 6. So arguments of s, which is this one here, plus arguments of t, which is this one here, equals arguments of s times t, this one here, and this is what I've been told to prove or asked to prove, and you got 3 marks. It's that simple. Just quick thing before we wrapped up, we've gotten here 4 sides. Yeah, when you try to calculate your arguments, first side there's no problem, keep it as it is, whatever you found, that's it. A second side, which is this one here, is simple as well. If you found basically if your imaginary number is positive and real number positive, imaginary number positive, keep it as it is. Real number positive, imaginary number negative, times it by -1 to make it positive. Done. If you're here, we go to this side in here. If your real imaginary number positive, real number negative in here, all you have to do, instead of keeping this same, what you have to do is p, which is all these degrees in here, minus this little angle in here you found, and you're gonna find your basically your angle. If it's the last one, this is the tricky one slightly, minus, which is for the real number is negative, imaginary number negative. It's the same calculation what we did for the third side, 1, let's say, or the second side, 1, 2, this side in here, but you have to time it by -1, and this is you're gonna be the result of your third side in here. Just see, but before you calculate the arguments, I highly recommend to go on the graph first, see where the angle is, where is your complex number, which what side it is, and then at least you got an idea which way it has to be positive or negative, because with just numbers it's going to be slightly difficult, so may confuse yourself. At the end you're going to make mistakes. This is all for our question for today. You see, this question got 2 parts, that simple, 3 marks, 3 marks. It was that easy, guys. If you need any question, drop me a text, or you need to do more practice. Maths, it's about practice. I will see you in the next video for more exercise and more topics to cover. Speak soon.